name is Anna Tenbenzo. Welcome back to my channel. I am exhausted. I am on, I think, problem number 5 today in these LeetCode problems, and this is number 78, subsets. So this solution today is going to be in Python. I haven't submitted anything for this yet, so I'm kind of excited to jump into this because this is kind of similar to the one we just did, which is number 77, where I beat 100% of users who use Python in both runtime and memory. So I'm having high expectations for this. However, I know and I understand that might not be exactly what happens. So let's go ahead and start this timer and read this problem a handful of times. So again, this is number 78. 78 subsets. So given an integer array nums of unique elements, return all the possible subsets, the power set. The solution set must not contain duplicate subsets. Return the solution in any order. Okay, so my example here is 1, 2, 3. So we have 1, 2, 1, 2, 3, 1, 3, 2, 3, 1, 2, 3. Okay, so then 0 would just be blank and 0. And it looks like we are capped off here, and all the numbers of nums are unique. Okay, so one more time. Given an integer array nums of unique elements, return all possible subsets. Okay. The solution must not contain duplicate subsets. Return the solution in any order. So this feels like we need another recursive approach. And to be honest, if you guys watched my last video, I think we should do that backtrack function. We should start kind of the same way that we did in the last one. But I think what I'm going to need to do is set 2 parameters in this case, which would be start, which would effectively represent the current number in the index to consider, and current subset, which would be the current subset that's being formatted, or formed rather. So not quite the same as the last video, but eerily similar. So I'm going to just start with what I said here with backtrack, and we're going to say start current subset. So inside of this backtrack function, I want to say something along the lines of if start is equal to this nums array, that means we've covered all the elements from the subset. So we're going to say if start is equal to the length of nums, then we need to append a copy of the current subset to the subsets list. So, and like that would be actually like a necessary step to avoid modifying the same results to like same list to those iterations. So we're going to say subsets append current subset. And then just return. So then we would have 2 choices in each element in that nums array. And that would be having to include the current number in the subset. But we'd have to append it. Yeah. Yeah. So we're going to take that current, because what we need to do is include the current number, and then we need to exclude the current number. Which sounds redundant. I understand. But if we include the current number in the subset by appending it to the current subset and making a recursive call to backtrack and start, then we can increment that by 1. So let's just do that. Subset append, must say nums start, and then we can backtrack, start, increment, and current subset. Now we need to exclude the current number, and by doing that we effectively are popping that subset out from the current subset and making the recursive call to backtrack and then increment that by 1. So just essentially popping it out to store it. And then we need to increment the start by 1 of the current subset. However, I don't have a place to store the subsets, so we're gonna make a place right here to store them. How does that sound? And okay, so if we have a place to store them, then we need to start processing these. So subsets. Let's say backtrack. Oh. So this will process those, and then we can just return subsets, which will just give us all of the possible ways to do that. Oh man. There we go. I mean, this should work in theory. So given an integer array nums of unique elements, return all the possible subsets, the power set. The result must not contain duplicate subsets. As it stands right now, this shouldn't give any duplicate subsets because it'll just pop it out. Just and you can return them in any order. So I don't think we'll have any duplicates. So we're going to store the subsets here. I could probably move this, but you know what? Nah. Let's just run it. Let's run it and see what's going on. Very nice. Very nice. I like it. I like it. Excuse me, please go down. Okay. That feels pretty good. That feels positive. Again, worried that I didn't consider an edge case in there, but overall, I feel like this recursive helper function is great for this subset, and kind of like then the last problem 77 too, that it just feels like that is probably the path of least resistance for all of this. And hopefully I'm not missing any edge cases, but we're just going to submit it and find out. So dang, girl. Ooh. Okay. So it wasn't as good. It wasn't 100% on both, but we had 99.27% in memory. We beat 99.27% of users who use Python in memory. Runtime 77%, but you know what? I will take it. I will take it all day, considering I have done 5 LeetCode problem videos, or 6. I've lost count if this is the 6th or the 5th and my brain is ready to take a nap. So I feel pretty good about this. I think I've mastered these recursive helper situations. This is about 10 minutes, because remember, I usually think about it a little bit before I start a video, so I'm a little bit more cohesive with my thoughts. But yeah, okay. I am pleasantly surprised by this. So I will leave this in the GitHub repo, which is linked down in the video description below. You guys are more than welcome to fork it and clone it. Make it better. Actually, please make it better. I would actually love to see this hit 100% on both, like the last question. Make it better. Make it worse. Have some fun. Learn something new. And I will see you guys in the next video. Thank you so much for watching. Goodbye.